Hey there, mathletes. Look at where we are this week. Week 1, we were in my classroom doing our videos. In week number 2, we were at Archbishop Moeller in one of the classrooms there, Mr. Kuhlman's class, doing our videos. This week, we're in Mr. T's kitchen. Where will we be next week? Who knows? It's kind of fun to see the different places we're coming from. I wanted to mention something. If you watch these videos, especially the midweek hints video, and I see on my YouTube channel, I'm getting a lot of views on that. If you're watching these for information and you're not checking the posts on the website, make sure you're checking the posts. There was a couple small errors last week in week 2, and we set up some different ways of dealing with those. So if you didn't catch that last week, I may owe some of you like a point. So please let me know using that one email, tarnowskip746@gmail.com, where you submit your bonus stuff. Send me a question if you think I owe you a point from last week or something like that. But I think most of that got taken care of. All right, now moving on. This is the week 3 midweek hints video, and I broke one of the cardinal rules of teaching, which is having the first problem on a sheet of problems be one of the hard ones. You know, you really shouldn't start off with a hard one. You should start off easy and build up. But I think the first one could be tricky, depending on how you look at it. The question was, there was somebody who drove 35 miles. Now, this is different. I choose a different problem to use as an example. But in the real problem, it said somebody drove 35 miles to someone's house in miles per hour in one direction to someone's house, and then 40 miles per hour on the way back. And the total time that it took the person was 1.5 hours in the problem. And then the question was, how far did the person go in one direction? So I just made basically a similar problem, basically the same problem, but instead of 35 and 40, I made it 60 and 50. And so the question is, well, how far did the person go? Well, they went the same distance to and from, right? It was the same from one house to the other. So 60 miles an hour times, let's call it X, times the amount of hours in one direction would be equal to 50 miles per hour times the amount of hours in the other direction, right? So this guy's going a little faster, so it's going to take him a little less time. This person's going a little bit slower. It's going to take a little bit more time. Now, if you're like a 6th grader, there's a lot of algebra involved in this question. You might not have the background. I'm going to show you later, there's some tricks to do it without all the algebra. But let's say you know some algebra. You set it up with 2 variables like that. You also know that the time, the example I gave, instead of 1.5 hours on the real problem, I gave that it took 1.1 hours. So the amount of time going one way plus the amount of time going the other way is a total of 1.1. And what I did is I isolated one of the variables. I got the y alone by subtracting x from both sides. So y equals 1.1 minus x. Then I took that value and I plugged it in place of y on this equation. So 60x equals 50 instead of times y. I did 50 times 1.1 minus x. And then I distributed 60x equals 55. 50 times 1.1 is 55 minus 50x. I added 50x to both sides. I get 110x equals 55. I divide by 110, and x equals 0.5. Well, if x equals 0.5, then y equals 0.6, right? But the question was, how far did the person go? Well, let's look at the first person. 60 times 0.5, the person went 30 miles. This other person went 50 in that direction, and they went for 0.6 hours. 50 times 0.6 is also 30, so same distance, okay? Now, that's a lot of algebra. It's using the substitution method. It's really more of an 8th grade kind of thing. One of the things that you can do is you can just say if the total time is 1.1, you can just start guessing and checking. You can say, well, let's split the 1.1. Let's make 1 hour for this guy and 0.1 hours for this guy. They won't be equal. The distances won't be equal. 60 miles an hour for 1 hour is not the same as 50 miles an hour for 0.1 hours. So as you're guessing and checking, you might also notice, look, their speeds are in a 6-to-5 ratio. So how can we split up the 1.1 in a 6-to-5 ratio? And you'd be like, oh, 0.6 to 0.5, 0.6 plus 0.5 is 1.1. So that's one way of doing that problem, kind of without doing all the algebra. All right, so there's number 1. Now, you know how I'm not supposed to start off with the hard problems? Of course, which problem do you think I made also kind of hard that I'm going to do a hint on? Of course, problem number 2. I'm going to pull up a different whiteboard for that one. Here we go. Problem number 2. Problem number 2 says there's a hexagon with a regular hexagon, meaning all sides are the same, with a side length of 9. And of course, I'm not going to do the problem for you, so I made an example where the side length is 6. Okay, and we're going to show you some cool tricks to show you how you can figure out what the question asked is, what's the difference between the longest line that connects 2 vertices, which would be like from here to here, and the shortest line that connects 2 vertices, which would be any of the sides, right? Like from here to here would be 6, or from here to here would be 6. So we just got to figure out the shortest line between any 2 points is going to be 6. Just got to figure out how long this long line is. So one of the things that we do, I don't know if you, this formula actually is going to help you on another problem later on in the set of problems, but it says that the sum of all angles of any polygon is equal to the number of sides minus 2 times 180. So 6 minus 2 is 4 times 180 is 720. So the sum of all angles of a hexagon is 720. Then, if you think there's 6 angles, we do 720 divided by 6, we get every angle is 120. So this angle is 120, this angle is 120. This big angle here, right here, is 120. But if we draw this line straight across it, we split that angle into 60 and 60, okay? All right. Now, if this angle is 60, and we drop a line down there to make a right angle, to make a right triangle, that's 90, which means this angle up here has to be 30. So what we've created is a very special type of right triangle. It's called the 30, 60, 90 right triangle. All right, there's on that sheet that's on the website, Mr. T's Math Must Knows, you should know the 30, 60, 90 right triangle. So anyway, in such a 30, 60, 90 right triangle, the shortest side is always half the length of the hypotenuse. So if the hypotenuse is 6, the shortest leg is 3. So if this is 6, this is right here is 3. And then of course, if this line is dropped down there, this is 6, so that's 3 and 6. And then this is like the same triangle over here, so that's 3. So 3 and 6 and 3 is 12. So the longest line is 12. The shortest line is 6. So 12 minus 6 is 6. So if the problem had asked you what's the difference between the shortest length between 2 points on a hexagon and the longest length between 2 points on a hexagon, then it would be 12 minus 6, which would be 6. But your hexagon is 9 in the real problem. All right. Next problem, to give a hint on, problem number 9. Yeah, you can't see me right now. I'm not on camera. All right. Here's problem number 9. Problem number 9 says, what is the area of a triangle with sides length, and I believe it's 10, 10, and 16. Okay, but it doesn't tell you what the triangle looks like, if it's an isosceles triangle, if it's a right triangle, if it's a scalene triangle. It's kind of hard to tell. Okay, now, you would know if it's 10, 10, and 16, it's isosceles. But what I did is I made a similar problem with different side lengths. Instead of 10, 10, and 16, I made one with 5, 5, and 6, right? And, we could draw it like that. That looks like an isosceles triangle, but do we know that that's the base, right? What if we spun it? Is 5 the base? If so, what's the height, right? How do you find the height? So there's another kind of cool way of doing this, which I might show you in the wrap-up on Sunday. But this here, I love this. This is a thing called Heron's formula. No matter what the shape of the triangle is, if you know the length of the 3 sides, you can find the area. You don't need to be given something called the height or something called the base or anything like that. You just need to know the 3 sides. So the special Heron's formula says there's a special number S. And S is the sum of all the sides. We'll call the sides A, B, and C. Not like a Pythagorean A, B, and C. Just call the 3 sides A, B, and C. And we divide by 2. S is A plus B plus C divided by 2. So 5 plus 5 is 10 plus 6 is 16 divided by 2 is 8. And then in Heron's formula, the area of a triangle is the square root of S times S minus A times S minus B times S minus C. So 8 times 8 minus 5, which is 3, times 8 minus 5 again, which is 3, times 8 minus 6, which is 2. 8 times 3 is 24, times 3 is 72, times 2 is 144. Square root of 144 is 12. Pretty cool, all right? Heron's formula works if you know the 3 sides. So you've got the 3 sides for problem number 9. You can figure that one out. All right, and then one last problem I'm going to give hints on. This problem here, it's kind of small. Let's make this a little bit closer. All right. It asks, for what integer is 2n plus 9 the reciprocal of n plus 5? Well, the reciprocal of n plus 5 is 1 over n plus 5, okay? Because it's n plus 5 over 1, we flip it, it's 1 over n plus 5. So I made another example, similar, different letters, different number, well, same letter, n, but different numbers. For what integer value is 4n plus 7 the reciprocal of n plus 1? So I wrote it out as an equation. All right, 4n plus 7. I put a 1 underneath there. So what I have is a proportion. And with a proportion, we can cross multiply. I guess you know how to cross multiply. Cross products are equal. Okay, so 4n plus 7 times n plus 1. Now look, if you're a 6th grader, you've probably never multiplied binomials. I'm very impressed if you have. There's a method called FOIL method. But anyway, if we multiply those 2 binomials, FOIL stands for first, outer, inner, last. First of that binomial times first of that. 4n times n is 4n squared. The outer terms, that one times that one, 4n times 1 is 4n. And the inner terms, 7 times n is 7n. And we put them together, 4n and 7n is 11n. And then the last term of that binomial times the FOIL. First, outer, inner, last. I don't know if that's too small, if you can even see that. The last term of this binomial times the last term of that binomial is 7 times 1, which is 7. Okay. Don't worry, by the way. I'm going to show you a different way to do this in a second. But when we do something called quadratics with squares, we like them to equal 0. So I'm going to subtract 1 from both sides and get 4n squared plus 11n plus 6 equals 0. And then I'm going to reverse that FOILing process. It's called factoring. I'm going to say 4n times n is 4n squared. My outer term, 4n times 2 is 8n. My inner terms, 3 times n is 3n. Put them together, that makes 11n, and 3 times 2 is 6. So this times this equals 0. Well, whenever we multiply two values together to make 0, one of those values has to be 0. So let's look at this value here. If I put negative 2 in for n, negative 2 plus 2 is 0. Anything times 0 is 0. So n could be negative 2. And then look, we can plug it in and see if it works. I know I made a mess here, but would negative 2 work right here? 4 times negative 2 is negative 8 plus 7 is negative 1. Over 1 is negative 1. Negative 2 plus 1 is negative 1. 1 over negative 1 is negative 1. Negative 1 does, in fact, equal negative 1. So negative 2 worked. All right? Now, how many of you guys know how to do quadratics? I don't know if many of you do. I'm impressed if you do. But look, you can always just guess and check. All right? Once you know what it means by reciprocal, you could start, and it says it's going to be integers, you could start just trying integers. Like, let me try 10. Plug in 10 for n. 4 times 10 is 40 plus 7 is 47. 10 plus 1 is 11, 1 over 11. 47 is definitely not 1 over 11. All right, let me come down a little bit. Let me try 5. 4 times 5 is 20, plus 7 is 27. 5 plus 1 is 6, 1 over 6. 27 is definitely not 1 over 6, but they're closer, which means we're getting there. All right, let's try 1. All right, 4 times 1 is 4, plus 7 is 11. 1 plus 1 is 2. 1 over 2 is a half. 11 is definitely not a half, but you see we're getting closer and closer. I didn't try 0. I guess I could have tried 0, but I'm going to jump down to negative 1 because that's kind of cool. 4 times negative 1 is negative 4 plus 7 is 3. Negative 1 plus 1 is 0. You're not allowed to have a 0 in the denominator. I don't know if you guys knew that. All right? So it's undefined. You're not allowed to have a 0 in the denominator. So anyway, 3 is not equal to that. But let's keep going. We kept going. We try negative 2 now. And we already know it's the answer because we just did it. 4 times negative 2 is negative 8 plus 7 is negative 1. Negative 2 plus 1 is negative 1. 1 over negative 1 is negative 1. Negative 1 does, in fact, equal negative 1. Check. There we go. All right, have a great rest of the week. Remember to email me if you have questions or issues about points or bonus points or things like that. Look for, if you haven't seen it yet, look for the post about the bonus challenge for the week, which will, if you're watching this on a Wednesday, the bonus challenge will be put out today as you watch it on a Wednesday. All right? Have a great week, guys. Thank you.